the articles that I write, I try to design my projects such that if you don't have it not into CNC yet, that the projects can be built, most of them, with just manual machines and that sort of thing. But I'll tell you, the CNC makes it so much easier. I started out, with manual machines, a little Sherline blade, Sherline mill. I moved a couple of little machine shop machines. I actually took one mill that I bought from the little machine shop and says, I want to do CNC, and I converted that over. And there's a did an article series on that. Then I got the Tormach, and that was just I learned kind of what I needed to know building the little machine shop, a conversion that I did. But learning Mach 3 and that sort of thing, and set my Tormach PCNC 440 up on the bench, unplugged, hooked everything up, plugged everything in, turned it on, and immediately it went apart. And that was that was great. And so I really enjoyed it. That sees more use in my shop than most of my other equipment. Anyway, the things that I build. The current project that I've got going on right now is a model of a backhoe. Some folks like to call it a steam shovel. But the backhoe is a gasoline engine device that came in just after the steam shovel age of construction machinery. It's kind of a freelance, an approximate model of one of the machines my grandfather had. I believe he had 3 of the machines. My dad operated one of them, and he would take me to work with him occasionally when he was going to dig a basement or something like that for a house. And he would set up and start doing his job, and then this was back during the day when you just told the kid, okay, stay out of trouble, and while I do my work. And so I would watch him, reaching out with the backhoe, digging the machine and that sort of thing, or digging the hole, and eventually I'd play a little bit around the job site or whatever, and eventually I would get cold or tired or whatever, or bored as a little kid did. And so he'd invite me up into the machine, and there was a place where he had a toolbox sitting next to the radiator of the engine. In the back behind where he was working, I could sit back there and get warm enough with what little bit of heat came off the radiator or whatever, and watch the gears and the clutches and the drums spinning and the cables in and out, and if you've ridden inside, you see these things, they're swinging back and forth, and they're digging, and they're bouncing around a little bit with it. And just a great thing for a small child. Well, apparently it influenced me, and later in life. I didn't stay in the excavating business. I went off to the Navy and learned electronics and that sort of thing. But it stuck with me, and finally it came to the point where I think I would like to, model one of these machines. And so this is how far I've gotten right now. This is running in a series of Digital Machinist magazine, and made pretty exclusively. There's some turn parts, but pretty exclusively with my Tormach PCNC 440. It actually, we'll talk a little bit about one of the parts. these are just some simple pulleys that I needed for the project. And I went ahead and said, well, normally a pulley, you would think of that as a lathe project. And I thought, well, yeah, but I needed enough of them that I, really, manual lathe, I didn't want to take the time doing all that, having to turn them over to machine both sides of them, that sort of thing to get the nice cross section that I wanted. So I went ahead and designed it to where I could machine out, one side at a time. And I set it up to where, I would just kind of profile out a hub here, and then when I had a taper here, I used a, I can't even think of the name of the tool here, but it's actually I used the shape of the cover to give me the angle that I wanted there. And then, drilled the holes and that sort of thing. And then I profiled out the shape of it, left some tabs so that I could turn it over on the mill and do the same operation. Now, I did 6 at a time on the one side, but I had absolutely no confidence that I could fixture it perfectly enough that I could flip it over and do everything else on the other side. So I did only 1 at a time on the opposite side, and I was, confident there and able to do all the milling work on each one of these, 1 at a time. Just moving this over on the dowel that I set up on the mill table. So, that only gets me part way though. I've got the profile of the pulley here, but I don't have a pulley groove. So what I wound up doing, and we'll go ahead and pass that around. Go ahead and pass those around too. Wound up, the groove for the pulley was going to be lathe work. And I thought, well, I want to try to see if I can do this completely on the mill. So what I did is I made an arbor to fit in the spindle of the mill, and just the thing where I could drop the center hole of the pulley over a little bit of a hub on the arbor, put a screw through there, and then tighten it down, put it into the mill, and then I just, on the milling vise, I held the cutter 90 degrees out and actually brought the spindle down, brought the table back and forth to feed the cutter in to cut the profile or the groove of the pulley, and so it came out very nicely. I was really pleased with them, and we wound up with all the pulleys I needed for the project. Plus, I did a bunch more just in case, and they'll be coming around with it. So, a little bit of imagination, and you can do a little bit of lathe work and that sort of thing on the mill, and wind up with what you need for the project, for the part. Now, the rest of the parts, and usually I have a few trial parts and that sort of thing, and I didn't have any of those to bring and pass around because I was able with the mill to design what I needed, profile it out. And that's most of what I did was profiling, just profiling out full thickness pieces of metal. Profile it out and assemble it. So first time, every time, with a little bit of planning ahead and fixturing on the mill and just turn it loose and let it go. This is running a series in Digital Machinist, and I'm working right now. In fact, this week and next week I'll be finishing the 4th installment Now, Quarterly Magazine, my fourth installment on this project has been running for now a year that I've been working on this project. That's kind of the nature of magazine publishing. Is I would love to be able to put the whole thing out there so that you guys can take the project and build it and move right along and but the constraints of the publishing business is, well, you can only have this many pages in a magazine to say what you need to say. So you got to go say part of it. So I have readers clamoring to me on the internet and that sort of thing. When are you going to have the next one out? When is the next magazine coming out? And it's just, I hate it. That I can't put it all out there once for everybody. Our editor, George Bullis, he's over there somewhere. He hates it that we have to do it that way. The readers hate it, but it's such as the way it is in the magazine. Now, for some of my other older projects, George saw fit to bring some of my older projects together, get them all pulled under one cover. So, the guy that wants to go gung ho in doing a project, he's got the whole thing right there. Occasionally running the series, and ideally I should have all this finished before you see the first issue of it, but I've never been able to get to that point. I'll start on a project and get the basic design done, and then it's deadline time and we've got to present something. So okay, well, we're going to get started on this, and we're going to be hopefully have the idea down well enough that we're not going to get partway through and we got a mistake, we're going to have to publish an errata. You guys have got a part that you've made that's beautiful and just like what we designed and it's wrong, and I have to ask you to redesign it. We've been pretty good about not having to do that. I hope to continue that. But the way that I've been publishing these things as I go along, that could happen in the future. So I'll say right now, I'm sorry for that. But let's see. I could do a real quick, put the microphone down and I'll do a real quick demonstration here for just a moment about what we've got so far on the project. And later on, after I finish with the talk, there's a few minutes you can kind of come up and have a good close look here. Otherwise, we'll be moving it back into the other room, and that and some other projects that worked on will be available back in there. Let me set this down for just a minute.
And where is the machine?
And I heard somebody say no servos. Well, that's part of the ongoing magazine project. Yeah. And yes, servos would be great in here. But the design or the intent of this particular project is I will be running the cables or the strings here that I've got, but the cables that will be running down through some pulleys and down through the center shaft after the tracks and everything on there. And underneath the cabinet will be some cams, which will run, be driven by an electric motor, and the cams will cause this to go through kind of a routine where you reach down, you scoop up a bucket of dirt, swing over, and then dump it into a hopper, and then the hopper will return the dirt to the sandbox here, so to speak. So it'll run without intervention. Could use some servos and manually operated if you wanted to. I believe there's room inside the housing here for for some servos and that sort of thing. So if you wanted a manual control, you would have that. If you wanted to follow what I'm going to be doing in the magazine article and just stand back and watch it run, that would be available. Or even just pulling the string yourself. After we're done, I'm going to welcome the young man sitting here to come up and actually, do some digging with it. So, and you'd be surprised at how fast, especially these young guys, will pick it up. It's just, he'll do great. It'd be a good grandchild project, or good for an old man too. So, let me talk a little bit about some of the other projects I've done in the past. Those of you that have read Digital Machinist magazine, I wish that I had more room to bring more stuff because I've had a really good time doing writing for the magazine. If you go online, you may be able to go with your cell phone and Google Wes Bye magnetic clock. You will find mostly stuff that other people have presented online. I haven't done any YouTube videos of it myself, but you'll see other people that have photographs and videos of what they've done building my projects. That magnetic clock was a very popular project. The tough act to follow. More people have built that clock than any of my other projects that I offer in the magazine. I've got readers, I guess most of the English-speaking world that I know of, Canada, New Zealand, the UK, Australia, that I've been in contact with and here in the States that have built the clock. And I wish I could talk more about that now, but it's kind of hard to describe. There are no teeth on the gears. The gears don't touch each other. I use magnetic fields to couple the gears together. As I say, go online and have a look, and you may find that of interest. Something that I can say is in the projects that I present in the magazines, my readers invariably do a better job on the projects than I do. Better surface finish, more polish, that sort of thing. I'm presenting mostly, the principles, basic project, that sort of thing. But then, with an active writing career where I'm doing an article every 3 months, when I finish a project, I have to move on to the next thing. I may not have time to polish and that sort of thing, but my readers, they have the time and they do an excellent job. And it pleases me to see them do something better than I do it. Because it shows that they really care about that project and how they're doing something that they're doing for themselves. Many of them had their own little changes, their own little modifications, that sort of thing, to the basic project and improve it. Although I did run across, I was just on YouTube once looking around, and I ran across a project that I says, I did that project. I don't remember putting it on YouTube. And I looked closer and closer and closer. I looked and realized I didn't do that project. But that reader, and I've never had any contact with him, that reader just picked up the magazine from the store or something like that, and did the project so faithful to the drawings, to the to the photographs, that I had a hard time distinguishing it from my own work. So I guess I was flattered with that. I guess what I'll do at this point is open it up to some questions and that sort of thing. Anybody have any questions or comments? Yes, sir.
What sort of repeatability and accuracy have you been finding with your work?
I probably was a good one to answer that question.
So let's repeat what was your question?
My question was what sort of repeatability and accuracy he was finding with his 440?
What kind of repeatability and accuracy was I finding with the 440?
I know what the spec sheet is.
Okay, you know what the spec sheet is. This is your 1.8 foot.
Yeah.
So 10 inches of travel. 1.3 on the 440. I don't know, what's your experience?
My experience is probably doesn't repeat very much because most of what I do is I design for my readers basically. You see, if I can do it, I want the readers to be able to do it. So I design most of my stuff to not require a lot of accuracy. I don't want to hear that. But no, I try to make it as so that the nature of my projects don't require a lot of accuracy. I guess it's no close tolerances or that. Sorry, I can't give you a better answer.
No, that's fine. I just thought as a pretty much heavy user of the machine, I just wondered what you were running into.
Other questions? Yes, sir.
What step do you find takes the longest when you're trying to start a new project? What do you spend the most time on?
Generally speaking, the most time is preparation and the actual drawing work. And when I do the question was, what part of the project takes the most time? And from a publishing point of view, I'll say the drawing, the dimensioning of the drawings, and that sort of thing. Now, when I come up with a project idea, I'll spend some time just kind of freehanding the CAD and that sort of thing. If there's anything like fasteners or standard shaft sizes, or if I'm designing around a particular purchase item, I will draw that in as accurately as possible, or import, say, manufacturer's drawings of a part or a gearbox or whatever. And at that point, then I start drawing around it and just work things together to see how things fit. When I'm satisfied that they works well in the on the drawing, I may even make a model. And generally, when I make a model, especially with a sheet metal or some of this stuff, I'll actually make a paper model and tape it together and see how it looks. Or maybe a proof of concept model to quickly just machine something, check a concept, make sure that it's going to work. Then I'll actually, especially when I'm using the CAD and I'm machining or designing for CNC machining, I'll draw the drawing up accurately, but I won't bother with putting dimensions on the drawing or anything like that, because I'm going to take the actual drawing, the actual lines, and I'm going to convert them over to a G-code. And here's the step that here's the train of events that I use. I do very little hand drawing or sketching anymore. That's used to be the way you had to do it. I work and the Fusion 360 guys won't like to hear me say this, but I'm a technological Luddite. I'm still using an old DOS version of Auto Sketch, version 2. I've saved up several old computers so that and old keyboards because it was made to use with the 84 key keyboard. But I will draw it up, and I'm very fast with that because I've been doing it. Muscle memory for working the keyboard and that sort of thing is all developed. But I'll sketch something up very quickly, dump it into vector. I use cut 2D vector cells would be absolutely adequate for everything I do. But I've got their next version up. The Pro V card. I'll dump it into there. I'll use that to massage my DXF drawings that the Auto Sketch will generate. Use that to generate the G code, and then from there I dump it onto the 440. Now, Fusion 360 that they talk about, or that some other folks talk about here, we'll do that all in the same package. So, I have to recommend that because this Auto Sketch is not available. But anyway, so I go ahead and I get it all done. I'm making parts and fitting them together and all that, and I'm satisfied with what I've got built. While I'm writing the article, I may be writing a little bit about it while I'm doing it. I'm taking photographs if I remember as I go along, photographing every step of the way. Then I've got to go back to answer your question. I've got to go back and I've got to make drawings that I can send to the public, to my editor, that are understandable, so that he can make them presentable to show up in the magazine. And dimensioning drawings is part of that process. So I have to go back and I have to put dimensions on everything and hope that I can dimension them in a manner that makes sense either for manual machining or for doing layouts. Because most readers, when they get the magazine, they'll look at the drawings and they will make their own CAD files from those drawings. They'll actually redraw my drawings. So they have it on CAD, and then they will generate their G code from their own CAD files. Now, occasionally, Village Press, Digital Machinist magazine, has a website, and occasionally we will put a file onto the website for download and that sort of thing. But it's pretty much there. When you're designing for a drawing in a magazine that sometimes winds up being a drawing design that may not stand the test of somebody will look at that and say, these two lines don't match or don't cross exactly where the dimensions say they do. But so occasionally we'll publish online some of the G code or some of the drawing files or whatever. So I guess maybe that's the long story to how I get what takes the longest is the dimensioning. Any other questions?
Thank you, Wes.
One step.
Leave it way out like that and drop it down. Okay, now just pull the one above the other
the thing that impresses me most was the choice of material. I mean, if you take, I've taken a lot of tools, you know what I mean? Everybody indexes.
There you go. Okay, leave it like this. Leave this one in. You're just fine. Hold it and pull this. Okay, now let this one go on while you're pulling that.
Yeah.
So if you work them together like that, you'll be able to get a full or a fuller bucket.
Oh, overloaded.
So what do you want to be when you grow up?
Scientist?
Awesome. There you go. Good to hear.
I'm making a mountain. Oh,
I let my grandkids play with it. You can't hurt it. I don't think. Kids are imaginative. They'll
what I
find a
can
way.
hurt is a little rock.
Well, thank you.